A of this question, what we've got to do is look at the forces in the J direction. So we have the weight force acting down, which is mass times gravity, 700 times 9.8, and we've got the lift force acting upwards. If we look at the resultant force, that will give us mass times acceleration. So we put that in and we end up with an answer of 7,210 Newton. Given the balloon has constant acceleration, for parts B and C, we can use the constant acceleration formulas. So they're shown there. The remainder of this question, we need to start considering the balloon, the forces acting on the balloon in two dimensions, so both the I and the J dimensions. Part D is fairly straightforward. We just have our diagram and we have to label our forces. So that's quite straightforward. We have lift, weight, a resistance force and a towing force. For part E of this question, if we read the question, the balloon maintains constant altitude. So that means our J component is 0. There's no acceleration or even velocity in the J direction. In the I direction, we can work out the acceleration in terms of V, given that we know that the resistance force is a function of V. So if we consider that, we can sum our forces in the I direction, and the resultant force will be equal to the mass times the acceleration in the I direction. In question E, we had to find a function, or give acceleration as a function of velocity. Now in part F, we're using that to find the distance travelled when velocity is equal to a certain value. So what we need to do is give acceleration is equal to v dx. So by doing that, I can flip it, I can integrate both sides and get x as an integral of v. Part G, what we're doing is using the integral that we found in the previous question, and we're just solving for v such that x is equal to 100. So it's just a 1 mark question. We put it into our calculator and solve, and getting that right answer there to match the verify question gives us confidence that we got the previous question right. For part H, the key word in the question is hence. So we're using something from our previous question to help answer this question. So and it's asking us how long. So it's basically a time question. So what we need to do with this question is to give acceleration as dv to t, and because we know what acceleration is in terms of v, we can substitute that in, flip our integral, or flip our derivative and take the integral of both sides to get an integral with v in it and dv, and put in that value of v that we found in the previous question, and then we get how long it takes to tow for 100 meters.